Okay, so here's the video for section 4.6, isosceles and equilateral triangles. So today's whole section is about um, using these congruent triangle theorems we've learned to kind of make some generalizations about other triangles. We learned a few really big important theorems in this section, and probably some of them that if you thought about it, you'd come up with on your own. But yeah, we're going to kind of formally work them out. So first of all, we got to go back over to isosceles triangles. We already talked about this earlier on in the chapter. The two congruent sides of an isosceles triangle are called the legs. Okay, and remember, isosceles triangles have at least two congruent sides. It's something that's a little different from maybe what you learned in the past, but isosceles triangles have at least two congruent sides. Okay, um, and the side that's not congruent for an isosceles triangle is called the base. And then you have the vertex angle. That's the angle that's formed where the two sides meet. So angle 1 is the vertex angle up here where the two legs meet. And then the base angles are the ones where the legs meet the base at, so 2 and 3. And there's a couple of theorems about base angles and legs of isosceles triangles. So first of all, in order to prove them, we have to go back and talk about, we talked about on the extra day, and we reviewed for 4.4 and 4.5. There was another way to prove triangles congruent. Actually, there are a bunch of ways, but there's one more specifically, and it's the hypotenuse leg congruence. And that's if you have two right triangles, if the hypotenuse and the leg are congruent for both of them, then they themselves are also congruent. Okay, so that's going to be important for us because we're going to use this to prove something about isosceles triangles. So here we go. So I'm not going to go through the formal proof of it. I'm just going to kind of walk through the idea of it. Yeah, we don't need to go off the statements and reasons. It take a while to do that. But here's the thing that happens. I've got an isosceles triangle right here. So, excuse me, what I'm going to do first is I'm going to draw in a perpendicular line, like an auxiliary line, that goes from C to the base here, AB. If it's perpendicular, what it forms is two right triangles. And then what happens is, since the legs are congruent, those are actually the hypotenuses of the right triangle. And by reflexive property, I can say, let's call this CD. I can say CD is congruent to itself. So these two triangles here are actually congruent by hypotenuse leg. Okay. And if they're congruent, their corresponding parts, angles 1 and 2, are also congruent. And that's the first important theorem about isosceles triangles. Not only are the legs congruent, but the base angles are also congruent on isosceles triangles. Okay. Now, we're going to flip this the other way around. This drawing here is backwards. It says, hey, you've got a triangle where the base angles are congruent. So if the base angles are congruent, what's special about that triangle? What we do for this one is we do the same thing we did before. I'm going to draw in a perpendicular segment that goes through E to, let's call this, I don't know, H here. Okay, that's congruent to itself. EH is by reflexive. Hey, I've got two right triangles. What I don't even need to know that they're right. I just, as far as right triangles, I just need to know that those are right angles. And we get this. We get angle, angle, side, angle, angle, side. So the two triangles inside are congruent. And what happens then is, if those two triangles are congruent, hey, guess what else is congruent? The corresponding sides are. Okay. So for these two problems, if you have congruent sides, you get congruent base angles. If you have congruent base angles, you get congruent sides. More specifically, on any triangle, if two angles are congruent, the sides opposite them are also congruent. And on any triangle, if two sides are congruent, the angles opposite them are also congruent. Okay. So here we go. Here are our two theorems for this section. Well, the first two. Okay. The first one's called the isosceles triangles theorem, and what that states is if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if the two sides are congruent, the two base angles are congruent. And then the flip of it, the converse of the isosceles triangle theorem, if two angles of a triangle are congruent, then the sides opposite those are also congruent. Okay, so here's the first example that we're going to have you answer up for me on a multiple choice problem, is which statement correctly names two congruent angles? Okay, so yeah, I'll have a pop up, you make your guess, and then we'll talk. There we go. Okay, so we're back. We'll see here what we've got, but what we have to realize is we've got congruent angles, so we have to have congruent sides. So for those two sides, right here and right here, the question is, what are their opposite angles? Well, their opposite angles are right here and right here. And specifically, they're the big full angles because those are the big full sides. They try to make it tricky by giving you, you know, these extra drawings in there. But it's angle JMK and angle JKM. Here are our two congruent angles. Oops, right here. Not C, sorry, B. Okay. All right, next example then. Same thing. Which statement correctly identifies the two congruent segments? Okay. So let's see here. So look at the drawing, and again, it's going to pop up for you. Okay, so we're back now. So again, looking at the angles we have these two angles here, and this weird kind of angle M, this angle K. So PML, PKL. So the question is, what side's congruent? Well, it's got to be the sides that are opposite those, which are PK and PM, which puts us for an answer then at D, PM and PK. All right. The last couple theorems here are actually really quite, I don't want to say simple, but they hopefully do kind of make sense and are reasonable. And that's this. If I have an equilateral triangle, okay, they're up there already, but if I have an equilateral triangle, we stop and think about this for a second. Equilateral triangle. All the sides are congruent. So what that means is, hey, this angle is congruent to this angle because it's like an isosceles triangle. Legs, base angles congruent. But if I turn the paper now, oh, wait a second, these become the base angles the way I've got it, and so this angle has to be congruent to this angle. So basically, if you have an equilateral triangle, you have to have an equiangular triangle, and if you have both of those, then they're the same triangle basically. And that's what this theorem states. Okay, an equilateral triangle triangle's equilateral if and only if it's equiangular. And then this last part here is kind of hopefully kind of obvious. Each angle of an equilateral triangle has to be 60 degrees because if they have to add up to 180 and they're all the same, 180 over 3 is 60. So they'll all be the same. Okay, so for this next problem, okay, we're going to find the measure of angle R. Okay, so hopefully what we would catch with this, whoops, wrong button. We would catch with this is, oh look, I got a pair of congruent sides, meaning these angles here have to be congruent, angle R and angle P. Okay. And then specifically, if those angles are congruent, how much are their angle measures? Well, if 60 is already taken up, 180 minus 60 means there's only 120 degrees left for those two angles, but they've got to be congruent, so 120 over 2 is 60 degrees. Oh, so what this means is this is equilateral and equiangular. So 5 centimeters is the missing side length. Okay. So for this problem then, what's the measure of angle R? Well, the measure of angle R was 60 degrees. Okay. For the next problem then, the question is, what's the length of PR? Well, again, it's equiangular and equilateral, so side PR has to be 5 centimeters. Okay. All right then, now, for homework tonight, you have to solve for X and Y in this problem here. Okay. And your hint is use X and Y you know, on their own separately. But think about what kind of triangle we have to have here in this problem. Okay. All right. I'll see you tomorrow.